Saxon Algebra 2, Lesson 9. Greeting my students. Greetings. More than just one. I have multiple greetings for you. And I have good news. Do you see how I wrote the lesson number up here, which I always do, but I put a description up here? I'll tell you what that means. That means there's only one topic in this lesson to cover. Up until now, we've been doing mostly multiple topics. You know how there have been so many different review things? I mean, it's really annoying because the lessons are really long and really confusing. I know. Well, this time there's only one topic, so I went ahead and wrote it up here. This is a big fat hint to you guys. If I write it up here, that means there's only one topic. Yay, it's going to be quick and to the point. So let us dive in. We have been reviewing these what I call frickin' formula problems that are fractional parts of a whole. We started by saying that if you have a fraction, you can multiply that by the total group to get your special group. We said it works with a decimal as well. And we also said it works for percents, but you have to put the percent over 100. If the percent is greater than 100, we get what's called a peanut style or a baby Jesus style problem. If the percent is less than 100, we get, see, if you see it sort of like this and pretend that's the hot fudge, this is what I call a hot fudge sundae problem. And I got distracted because I didn't make this look like a peanut, so I got to go back. I'd hate to compromise your mathematical education by not making the percents greater than 100 diagram not look like a peanut. That I couldn't live with myself. Okay, and this is the ice cream sundae. So this is where we've been so far. I hope you're drawing those all-important diagrams. They better look good, you guys, because that's important. What we're going to do now is more of the percent style. So they might be peanuts, they might be ice cream sundaes. The new twist is that we're doing word problems, which honestly I think makes it easier because they make the scenarios make a little more sense when you have a story behind them. The only thing that annoys me about this lesson is that for some reason, John is choosing right now to make his diagrams squares and rectangles. They're so much better when they're circles. I'm sorry, John. I think you need to rethink your strategy there. I will continue to draw his circles. He's busy doing his own thing. Example 9.1. There are only two problems. We're going to be done in no time. And then you can do your homework. The wood nymphs and the maids gambled and frolicked before the banquet began. Okay, take just a minute. What is a wood nymph? I don't really know. Some sort of elf, I suppose? They live in the woods, right? And the maids, girls, right? They're frolicking and gamboling before the banquet. So just take a minute and picture that. I'm imagining little people with flower cups on their heads. I think that's what the wood nymphs would wear. A lot of purple. I don't know. Maybe some bark colored trousers. Maybe. I don't know. And they're dancing. Are they the same size? I imagine the wood nymphs as being much smaller than the maids. But I mean, if they're gambling and frolicking, wouldn't the maids be stepping on the wood nymphs? I'm not sure how they got around that problem because gamboling and frolicking is happy. And so if they were squishing wood nymphs, that wouldn't be good. Okay, anyway, as you can see, this really distracts me with a lot of side thoughts. Before the banquet began, okay? If 70% of those present were wood nymphs and 120 maids were present, how many wood nymphs came to the banquet? Okay, that's really confusing. So let me just show you. We've got a group that are wood nymphs plus the maids. All right, I'm not going to write all that out. I'm abbreviating, if you will. We can separate that group, pretend those are perfect circles and they're the same. The wood nymphs are 70% of those present. All right, so I'm going to make it kind of like that. The percents go on the outside. This is 100% of the group before we divide them. 70% are the wood nymphs. Well, that tells us right away that 30% must be the maids, right? It's got to add up to 100. And we're also told that 120 maids were present. Okay, so we can fill that in there. How many nymphs came to the banquet? So that's what we're supposed to find. Okay, well, a freaking formula means you take the percentage and you multiply it by the total group to get the special group. So if we want this, we would take the percent, 70 over 100, and we'd multiply it by this, which is the of number, the total group. But we don't have that number. So how are we going to do this? Well, our eyes drift down to this part and we think, well, wait a minute, we've got both parts here. Couldn't we use this as the percent and this as the is number and use it to calculate this number, and then we can go back and figure that out? Tricky, right? You have to be so clever to keep up with John. So that's what we're going to do. So step 1 is we're going to find the total group. All right, and we're going to use this data to do it. So I'm going to call this y so that I can set up a little equation. We're going to say 30 over 100 times y, we'll use x for that one, equals 120. Cool? Okay. I'm going to multiply this by 100 over 30. I'm going to use the reciprocal because I don't want to divide by a fraction. That's just too much, you guys. I can't. I'm going to put that over 1 so it doesn't look confusing. This all cancels and goes to 1. And y is by itself. Y equals, okay, 30 into 120, I know it goes 4 times. So y means that there were 400 of these persons, banquet goers. Let's call them banquet goers because they were all going to that banquet. There were 400 of them, assuming none of the wood nymphs got stomped. And so now we know the number of maids, we know the number of total. We could either take this 400 as a new of number and multiply it by our 70%, or we can just straight subtract, you guys. We don't even have to put ourselves through that. 400 minus 120, I can do it in my head. It's 280. And I can double check because if I multiplied the 70%, 70 over 100, oh, excuse me, times this, it would also be 280. So, I feel good about this as an answer, and guess what? It's correct. 280 wood nymphs were gamboling and frolicking in the forest, and none of them were killed. Okay, step 2 was find the special group. Okay, so this is a good example because it shows how sometimes we need to use all the information. Remember, John didn't give us the 30%. We deduced that. Once we knew the 70% were wood nymphs, we knew the other 30 had to be maids. If we hadn't figured that out, we wouldn't have had the information we needed. Okay, there's one more. This one is no longer about wood nymphs or maids, and I'm a little sorry to see them go, because now we're going to talk about a harvest. The harvest was cornucopian. You know what a cornucopia is, right? It's one of those like trumpety basket things that you see at Thanksgiving time. I don't know anyone that actually has one. You just see them like, I don't know, in photographs or illustrations or something. I've never seen one in real life. The harvest was cornucopian. It means bountiful, as it was 120% greater than last year. Okay, it's greater than last year. That means we got a peanut problem coming on, because this year's harvest, this is last year. This is this year. This year's is bigger than last year. And here's a part that's confusing. It was 120% greater. If last year was 120%, it was all of last year plus 120% greater. That means the total was 220%. The wording on these is so tricky, you guys. It drives me nuts. If I were you, when you're doing a problem like this, always check and make sure you got this percent right, because it's easy to misinterpret the words John uses to describe these percents. It's so confusing. So check that before you carry on with your work. All right, if the yield was 140, big number, how many bushels were harvested last year? Okay, so that's the X, and this is the number that goes here. Okay, let me read it again and see if it makes sense. The harvest was cornucopian, as it was 120% greater than last year. If the yield was 140,800, how many bushels were harvested last year? Okay, the diagrams are simpler in these peanut problems, but this percentage is always a little bit of a head game. Okay, so we're just gonna set it up. I'm gonna write this again because I don't have it on this page. All right, this is always the of number, and this side is always the is numbers. Okay, so our percentage, 220 over 100 times X, we don't know that, equals that big beastly thing. Okay, I'm gonna multiply this by its reciprocal, because I don't want to divide by a fraction, no thanks. Students often ask me, why don't you reduce this before you multiply by the reciprocal? You could, that's absolutely fine, and I encourage you to do that. I usually do it just with these numbers because I want you to see that that would work too. But if I could simplify this quickly to 22 over 10, or I could even take it all the way down to 11 over 5. So do it however you like. I just use the number as it is. Okay, so here's what we're gonna do. Now we're gonna do the reducing, right? Because we've got all of that is gone. We've got a cute little X, and we just have to simplify this mess, right? So the first thing I'm gonna do is I'm gonna divide top and bottom by 10, and it looks like me just doing that, crossing them out. Now I'm gonna say, sorry, I'm thinking about multiple ways to do this. Let's knock this down to, let's take 2 more out of it. Let's make it 5 over 11, all right? Now let's see if 11 will go into that big number. John almost always makes these come out nice and even for us. So let's see if he was kind as well this time. 11 goes in here once. We estimate, we multiply, we subtract, and we bring down. 11 goes into 32 times, so that's going to be 22. And look, oh my gosh, he's so sweet. 11 into 8, 88, sorry, and then 2 zeros. So this and this is what we divided. We got 12800, and then we still have to multiply that by 5. Remember, no calculators. Calculators are for the weak. We're strong. 10 plus 4 is 14. 5 times 1 is 5. So it looks like our harvest last year was that many, and I just looked at the problem to see what the unit was. It's bushels. Okay, and I can also write it here as another way to show the answer. This is correct. This is a great presentation, but I want that diagram to be full. Remember that the diagrams are a great way to organize the numbers in the beginning to help you figure out what you're doing, but then you have to go back at the end and complete them. And I always want you to fill in all of the blanks, because that's what makes it fun, you guys, is getting in all the little pieces of information. And then you can pat yourself on the back and go, dang, that harvest was cornucopian. I'm so glad I tackled that problem. But sad news, we are done. We're done. And so I turn you over to the homework for lesson number 9, and I will see you again very soon for lesson number 10. Goodbye.